Hi everyone, and welcome back to this channel. So in the previous tutorial, I said that for you to write an efficient algorithm, you have to know the right data structures to use. So that might bring up a question in your mind that what is an efficient algorithm? Or what determines if an algorithm is efficient or not? So I believe for you to have a full understanding of what the efficiency of an algorithm means, you should have an understanding of how the computer run your algorithm. So if you understand how the computer run your algorithm, then you will have a full understanding of what the efficiency of an algorithm means. And by the way, if you've not checked the previous tutorial I did, I'm going to put the link in the description so you can go there and check it out. Okay, so before we go into the actual way the computer runs your algorithm, the full breakdown of how the computer runs your algorithm, let's look at the normal way we run the algorithm. Okay.
Welcome back, everyone. So here, I have a simple addition algorithm that adds up two numbers and prints the sum. So basically, we accept the first number, store it in variable A, then we accept the second number, store it in variable B, then we add up the two numbers and store it in variable sum, in the sum variable, and then we output the sum. So this is kind of a very simple algorithm compared to what you're going to see or face in an interview, but it's still an algorithm. Okay, so I've saved this program in a file called sum.c++. Okay, so I'm going to click the run button to run the program. However, if this algorithm is implemented in a language like JavaScript, then we might need to type something like this in the command prompt to run the program. Or if this algorithm was implemented in a language like Golang, then we might need to write something like this in our command prompt to run this program. However, I'm going to use the compiler I'm using to run this C++ program. Okay. Okay, so I'm going to enter the value for A, which is 4. Okay, enter the value for B. So I'm going to pick a random number, say 8, right? So we are expecting 12 because 8 plus 4 is 12, right? Okay, awesome. So we got the expected output. So this is how you run your algorithm normally on a computer system.
Welcome back. So we've seen how you can execute your algorithm on a computer system. Behind the scene, running an algorithm requires some steps. Okay, and I'm going to show you the steps now. All right, so you write your algorithm in form of a program and store it as a file. So you can write it in C++. So you store it as a C++ file. You can write your algorithm as a Java code, right? Then you store it as a Java file. You can write it as a assembly language, right? Or you write it in machine code, right? So you have to write your algorithm in a programming language and you store it as a file. So that's fine. So in this case, the name of our file is sum.c++. However, a file is stored in a component called the hard disk. So the hard disk stores the files in our computer system. Okay. This is the hard disk. Okay. Now for you to run a program, okay, it has to be fetched from the hard disk to another component called the RAM. Okay. And remember, the name of our file is sum.c++, right? Okay, so like I said, the RAM has to store the program coming from the hard disk. However, the RAM can only store program in form of the machine code. So basically ones and zeros. And we are trying to move a C++ program into it, right? So that won't work. So it has this C++ code must be converted to a form that the RAM can understand, which is the machine code. Okay, so we need a software to help us with that. And in this case, we can use probably a Visual C++ or code block for this. Okay, so that can be okay. So the compiler takes the C++ code and compiles it to the machine code so that the RAM can store it. So I believe that is straightforward. However, the RAM has some specific properties, okay, and those properties are what defines its function. So what are these properties? Okay, so the first one is that the RAM is a volatile storage. So what is a volatile storage? This means that the RAM works as long as the computer is powered. So if the computer shuts down, the data in the RAM is lost. Okay, so that's one of the properties of a RAM. So the second property is that okay. So normally the RAM always it has a limited space, okay, compared to the hard disk. So the RAM can be like 8 gigabytes, 16 gigabytes, probably 64 gigabytes. That's basically your RAM. But your hard disk can be as large as 500 gigabytes or 1 terabyte, right? Right. So it can be so large. So we can see that the RAM normally has a limited space compared to the hard disk. Okay. So the third property of a RAM, which specifically defines its function, is that okay. So data that is stored in the RAM can be accessed as fast as possible. Okay. So to fetch data from the hard disk can be very slow. Okay, but to fetch data from the RAM is very fast. All right, so that's one of the main purpose of the RAM. So since we can access data as fast as possible from the RAM, it's better we pull our program from the hard disk to the RAM. Okay. However, the RAM stores the current program that is running, but it is not the one performing the execution. It is only storing the program. It is not the one executing it. Think of this as a man sitting on the desk and the man has files in his front. Okay, so the man sitting on the desk is working on the files that is on the desk. So the files on the desk is like the data stored in the RAM, and the man that is working on those files is another device called the CPU. So the CPU is the one in charge of the execution of the program stored in the RAM. So how this works basically, remember your RAM stores a program, and your program, there are steps of instructions. Okay, so the CPU fetches each instruction. Okay, so it fetch the instruction, right? Then it decodes that instruction. Okay, then it executes the instruction, and when it executes the instruction, it gets a result, and that result is stored back in the RAM. Okay, so I think you get the way this works now, right? So it fetches the instruction, decode the instruction, execute the instruction, and store the results back in the RAM. Okay, so yeah, that's fine, right? But your the CPU helps us run execute the instruction, but the major aim is to use that instruction to process an input into an output. Okay, so in this case, the program requires an input. Okay, now check this out, right? So the input comes from the keyboard, right? All right, so uh, basically the input always comes from an input device, like a mouse, like a microphone. Basically, any device that can convert data in a human readable form and convert it to the computer readable form is an input device. Okay, then at the end we expect an output. So okay, so basically the output comes to the output device, which for example in this case is a monitor. So an output device is a device that is able to convert data in the computer readable form to the human readable form. So I believe you get that. Okay. So now that we have this, let's review how the CPU works again, right? So the CPU fetch the instruction, decodes the instruction, execute the instruction, stores the results, okay? Then goes again, fetch the next instruction, decodes it, execute it, and store it. So this operation is controlled by another device, okay, called the clock. So the clock looks something like this. Okay, so when the clock flips to the left, that is a step fetch. When it flips back, decode. If it flips back again, execute, then flips again, store. So each tick means a movement from a step to another step. So if it flips like this, that can be a fetch, flips again, decode, ticks, execute, then like that, store. So the clock helps us control the way we move from a step to another step. Okay. All right. So I believe you get that now, right? So the number of ticks made by the clock before the CPU can finish executing your program is called the CPU time. So the number of ticks that the clock makes, right, before the CPU finish executing your program stored in the RAM is what is called the CPU time. And that is basically in seconds. You can also store this in number of ticks, but you have to convert that number of ticks to seconds at the end. Okay, probably milliseconds or something like that. Okay, so from this explanation, you can see that the two major resources that is consumed by your RAM is the CPU time and the, the space in the RAM. So let me write that down. Okay, so when I say, remember the first question. Okay, what makes your algorithm efficient? Okay, what is the meaning of an efficient algorithm? Okay, so what makes your algorithm efficient is if the algorithm takes the minimum amount of time possible to run by the CPU and it occupies the minimum amount of space on the RAM. So that's what makes your algorithm efficient. Okay. All right. So in the next tutorial, I would teach us how we can analyze our algorithm and see how it will behave as the input size becomes bigger. Because normally the time it takes to execute your algorithm increase as the input it is processing like gets larger. So kind of like the more the input increase, the more the runtime actually increase. Okay, for your algorithm. So I'll be walking you through how you can analyze that in the next tutorial. Okay, so thank you very much. Thanks for staying to the end of this video. You can like, comment, and share. I'll be so glad. And also, if you have any topic in your mind that you think we can discuss on this channel, put it in the comment box. I would respond to that. And please, okay, don't forget to subscribe. Don't forget to subscribe. It is very important so I can get notified when the next tutorial comes out. Okay, so please subscribe. All right, thank you very much, and thanks for staying to the end of the video. See you in the next tutorial. Bye.